Hello, everybody. So tonight starts module 2 in this nice long stretched out 16-week course. But if you haven't heard yet, this is probably going to be one of the wrapping up the 16-week courses, which you've probably noticed that having some 8-week and some 16-week kind of throws us off. We all get in that the pace for the 18-week courses, and then it seems odd in the 16-week courses. It's much better when everything's sort of consistent. So in the spring, most everything's going to move the 8 weeks. I think most stuff is anymore anyway. There's only a couple 16-week classes still, but we're in one of those that's still a 16-week course, so we're just now starting module 2. Got a couple things on the agenda tonight. Still looking at sort of the fundamental basic Java syntax, getting started with things. The two big ones to look at next are going to be arrays and methods or functions. So that's one of the things. We use those words interchangeably when we're talking. We're just speaking, talking to the team of programmers developing a big piece of software. We're going to use those words interchangeably, but at least keep in the back of your mind that there is a technical difference, because along the way you're probably going to have to take some certification exams. Methods are in object-oriented programming, and functions are in procedural programming, which there's not much procedural programming left in the world that we still do. Those are way, way, way down the list of most popular programming languages. Let's look at that list. I glanced at it over the weekend. Well, when we pull this up and just kind of look at the list, you'll know how to find lists like this. There's a lot of them out there. Most commonly used programming languages. I'm gonna take that last part off, because that's one of the things I wanted to look at. So we just look for Google most commonly used programming languages. Obviously, JavaScript is number one, because that's the HTML5 standard. I think we talked about it before. JavaScript and Java are not related. Java was very quickly becoming extremely popular in the mid-90s when they invented JavaScript. So they just kind of grabbed the name. JavaScript isn't even called JavaScript anymore. It's ECMAScript. But everybody uses the official term for it. So let's see where this list, according to Stack Overflow survey, which is one of the things I want to point out. When you look at a list like this, there's different ways that list can be taken, right? This one's from a survey. So right off the bat, you've probably heard that before. The statistics as far as they apply to people who respond to surveys. A lot of people don't respond to surveys. So in-demand programming languages for people who answer surveys on Stack Overflow. That's going to cover a lot of programming. It's probably a good sample size, but when you're looking at things like this, you might want to look at a couple different places. These all make sense, right? The HTML5 standards, along with relational databases, are definitely right up there at the top, because that's the stuff that's 99% of the sites on the web. All the blogs made with WordPress and Wix, using those. Followed closely by Python and Java. But always keep in mind things like this, where that data came from. It's a good idea to question and confirm everything. Right? It's like those numbers seem reasonable, but it's good to confirm it. A really good place to look for this question is what Google is remembering that I searched for earlier. I always say this word, people. It's supposed to be like high people combined into one word. Their list like this is they actually check the Google bots. Oh, that's not the one I wanted. So instead of asking a bunch of programmers and getting the results from people who answer surveys, if you add that to the list of most popular programming language, they're checking the bots on the internet. not the people. And if you ask a bot, it's going to give you a response. So there's going to be a much better response rate here. We get basically the same order. They disregarded the JavaScript and HTML because that's almost a trivial, most popular language. Yep, very few people refer to it as the coffee anymore. It was sort of a slang term for coffee, but that one kind of faded away, and now most people know it by the programming language. So sort of the same order here. They have JavaScript, but not JavaScript with HTML. That's like JavaScript, like oh Lord, just slipped my mind. The framework VS Code is written in. Starts with an E. The word slipping my mind, but the framework VS Code was written in JS Node. So that's that 10% of JavaScript they put back on here, but would be much better survey results from this because they're checking the bots on the internet. Nice little graph to show it over time and get a visual representation. And you can see that sudden increase that kind of pushes the other language above Java. There's some other things that happened in the world around that time as well. Right there where it starts, the blue line starts suddenly creeping upward is right around the time that there was that big breakthrough in machine learning, which we can do in Java, but that's not an issue that's not a situation where speed would be an issue. Right? That's something where we're going to get this program started and we're going to wander away, go get some coffee, do some other stuff, and come back and check the results when they're finished. So it's not time critical. So that's definitely a situation where we're going to go with the easier to use language when it's not so time critical, or we don't need as fine grained of control. But still a very, very commonly used programming language. And another thing with Java, that most popular programming language cannot compete with what we typically think of as using Java anymore. So the individual desktop apps, those are kind of fading out everywhere. The SDEV 220 class, I know at least one person had that, the software development with Python, took that with me in the spring with the old course shell, and the new course shell started over the summer. I was the first person to run that. And we're doing everything in that class, kind of like what I was showing here with the JSP, where we're making applications to run on the cloud anymore. Local computers, everything's on the internet, 5G connections all over the place, so there's plenty of transmission speed. We can use powerful servers to run the software. And that's where we use Java the most, big things. So as we talk about different things, keep in mind something like Humana. So if you're here in Louisville, you probably know some people that work at Humana, right? And that's a big company, 50,000 employees, 10 million customers. And at the beginning of the month, when they send out the bills, a very large percentage of them are going to need that to access the software, the company software at the same time. So when we're thinking about programming in Java and talking about, like last week, we were looking at data types and about when to use a byte versus a long integer, because obviously anything that fits in a byte, we can throw an L at the end and start having 64 bits. Just most of them are zeros. But when you have that many people using your software, those extra 56 bits add up very, very quickly into millions and millions and millions of bits and start to slow things down. So that's going to be an issue. We can talk about telemetry more specifically later. Right now, still in the basic syntax. Just want to make sure we're in the right frame of mind, because I think everybody in here has seen those easier to use programming languages. And as you do your homework, you're probably going to hit some frustrating points of like, I know how to do this without all the semicolons and curly braces and all those extra setup steps, which The setup steps are automated in Python. It's in the background. It's essentially the exact same thing. Right? Remember typing the guard statement in Python, SDEV 120, 140 class, or 220 for those who took that if name equals main, because Python just automatically renames your thing to main. In Java, we have to actually write the main and figure out and tell the computer where our starting point is. So those automated things move to the background. We still have to, the computer still carries out the same thing. But when the computer has it generalized, it has to generalize it for every situation. And there's a lot of overhead that really slows things down. So when we take fine-grained control over that, we get very precise control and very over how fast it's going to run, how effectively it's going to use our resources on the machine, all of that stuff. We get that back is the trade-off for that little bit extra coding that's probably going to seem frustrating having seen that easier language. Until about this, well, on that graph we just looked at, until just before where those lines crossed, and that one was moving up, the blue line was moving up, and the red line was moving down. Just before they crossed, but before that, in academia, it was always a big deal to start with languages like Java and C++, C#, and then learn Python, because it's much easier to go that way. When you've already seen the easy way, and then learn the more extensive way, I'll say it that way, the more extensive and thorough way, it's a harder transition to make. But going from the extensive to the easy one is a much easier transition. So we used to always go that way. But kind of like the machine learning thing. If we can get away, if it's not speed critical and we're not worried about that stuff, right? It's something we're just going to start the program running and go do something else, and we'll come back to get the results when it's done. We're not worried about any overhead or any of that. We're usually going to go with the easy way. But with that being said, got a few more things to look at with Java for the basic syntax. Two big things I put on the list for tonight are arrays and methods, which again, methods and functions, when we're talking, we'll use those words interchangeably. But the technical difference, the sort of thing you'll have to answer a multiple choice question about on a certification exam. The technical difference is methods go with object-oriented programming and functions go with procedural programming, like Fortran and languages that are almost never used anymore. So pretty much everything that we use these days has methods. And then arrays are actual arrays. Probably use that word in your previous classes. The prerequisites for this, even though we don't actually have arrays in those. Which one should I start with? I think I want to start with methods. We'll start with methods and then we'll get into the array. Then we'll talk about arrays. And I went ahead and for module 2, we probably won't talk about it until next week. But I went ahead and included array list and linked list, which are more like what you would have used in other programming languages, more with like what you're familiar with. The biggest issue being that they're dynamic. Arrays, real arrays, not just using that word generically as our generic catch-all term. Like when we search for stuff, we just say Google it, no matter what search engine we're using. Instead of using arrays like catch-all term, we're using actual arrays for fixed size. If we say we have 7 integers, that's it, we cannot store 8 integers there. The only way we can store 8 integers is to make a new array that will hold 8 integers and copy everything over. So they're non-dynamic structures, which is why I went ahead and included the array list and linked list like you're used to working with. But there's some details I want to talk about because eventually this semester we're going to make a big deal about telemetry. That's why I keep mentioning it. It's going to be that's a big deal. That's why we want to use the more extensive language when we get that refined control. And we're concerned about how much of the RAM chip we're using. We're concerned about how fast it's going through memory and things like that. But first off, methods, because I want to get to this, since that thing that we saw the first couple weeks looking at doing new programs in the traditional main method where it runs on a local machine versus the JSP, the Java server pages where we embed our Java code into HTML code and can make really nice looking output instead of just console output. Those have been like separate things, but when we have methods, and the first thing we're going to see here, we'll be able to tie them together. So we'll be able to make our applications and have a main method and a JSP. And it's only like going to be like an extra line of code to call that. So I'll go ahead and share the screen and open up NetBeans and kind of start into this. I guess the quick version of it, the first prerequisite for this class, and we've already called is like is modularizing our code. Pictorially, while NetBeans opens, we might have some fancy flowchart going on. From a start, come down, go through a selection structure. Maybe this side has some looping going on. This side hits another selection structure where it might just jump to the end, or we might do a whole bunch of processing along the way. And somewhere down here, I think I kind of messed up the picture. Somewhere down there, we get to the end of the flow chart. It all works, but it's kind of a lot to deal with at once. So it can be a good idea to sort of reorganize that. So take and put all of those in one place by themselves, or this section over here, and sort of organize that into its own little module that's separate and independent, so it would be reusable in different situations, as well as easier to deal with when we're debugging and stuff, because everything's in small chunks. So we can just make sure each small chunk works instead of that entire picture. Okay, looks like NetBeans is open on my computer now. So modularizing our code, breaking it down into pieces to make it easier to work with. And we've already seen some. And since I'm excited to show this, I'm gonna create a new project like we've seen. When we're making things with Java, we're usually thinking about big things and all of that stuff that languages like Python do in the background for us, we have to do. Kind of. A lot of them are automated processes, so we'll still have the computer automate it. Maven is probably the most popular way to package your project. Gradle is what Google likes to use. Ant was one of the first ones they came up with. And so Ant is a little bit more in human readable form, because when the guys came back 6 years later, yes, made Ant, came back 6 years later and made Maven, they had lessons learned, and one of those being like, why did we put automated processes into a human form? So Maven is a lot more computer form, and it's not very friendly for, not as human friendly to work with. So Ant is a good start for the class, and we'll look at the other ones before long. Instead of doing a Java application and put in a main, and then coming back and maybe doing the same thing over in a JSP page, I'm just going to create a new web application and do them both right in the same one this time. Because I've been very excited to get to this part and show how we can do both of them at the same time using methods. Web application 1, that sounds like a good name for it. Well, it's probably not going to be all recognized on GitHub. Set 6 methods. That way the file is easy to find on GitHub. The folders are easy to find on GitHub. Need to look at them. We'll see what that checkbox is for pretty soon. When we get to MySQL databases, then we'll probably see that checkbox before then. And then which server do we want to use to run the web components? We went through this the other day. You install Jam on your computer, that's a ready to go Apache server, Tomcat server. it's got a whole bunch of things ready to go on there. Tomcat is Apache's server product, web server product that runs Java. And if you need to, just search for it. Tell NetBeans you're looking for Tomcat and browse to the location, which should be in your XAMPP install. So the default would be right at the top of the C drive. If anybody's on a Linux system and you use the default, it's in the opt drive, OPT, top level drive, but should be fairly easy to find. And when you go in there, there's a folder called Tomcat, and you want to select the folder that you can see bin inside, because it's going to use all of the stuff in all of those folders. So I always just go to the folder that I can see bin inside of, and then that's where we need to point to. But NetBeans will remember it. So if you've been there once, it'll remember it. I would highly recommend creating a new user and password for NetBeans to use on that server. If you can do that, just put something in there, create a user if it doesn't exist. It will remember the ones you've done before, so it'll keep that on there. Give it some context paths. We don't need any frameworks yet. The frameworks, we'll talk about those at the end of the semester. Those are for really big things. Can't even throw all the words out yet. I guess everybody would have seen some object-oriented programming. And when we make objects, which everything in Java is an object, we put a constructor together, that initial creation piece. And when we create an object through that constructor, we get a really nice, fancy, one-of-a-kind object, like our precious little data type that we want to hold and take care of and keep around and manage carefully. But that's not always the best option. Another popular alternative is what we call factories. We'll see those later in the semester, where instead of creating that nice, fancy, one-of-a-kind object with a constructor, we create a factory that spits out a bunch of disposable objects. So anytime we want to call a method, we quickly create an instance of that object, use that one method, call that one method, and then delete the object. They're more effective. And then there's things even better than factories. And they're built into the framework. All of that stuff is built up, ready to go, so that we can build those big pieces of software for things like Humana, where there's 50,000 employees and 10 million customers. And we don't have to start from scratch every time. So it's a lot of advanced features already built in, is what those are. We'll take a look at them at the end of the semester, but it is a one semester course. So it'll probably be a quick look at those when we get to them. So it created an HTML page. I'm going to delete that in a moment and replace it with the JSP page. But we're going to talk about methods. So I don't need either in HTML or JSP. I need a Java file. So down here, you'll notice this file for source packages. That's where our Java code goes. So in source packages, or if you're ever not sure where to put them in the projects, like all those automated processes that keep things organized and straight, you can always right-click on the top level of the project and create and go to new there. So we want a new Java class, and then it will put it in the right spot. I'm just going to call this methods, or a bit of one beside it. Not sure what else we're going to do. If we just click finish, it would put it in the default package, which is usually considered bad form. We want to organize our things better than that, right? We're already several layers of folders deep here, so what's one more folder? And the starting point on what a package is that's the folder we're in. I'll just call it methods again. I think it'll be okay to use the same name. Now we'll click finish. And it created that new folder, which will have some other stuff, especially when we get over to the to looking at the Java comments, where the comment will generate an entire website for us. Right now, I'm just going to get that out of the way. And you'll notice the first line that's not a comment refers to the package that we're in. So it refers to the folder name. That's very important. And we have already seen method sum, right? In order to start our program to begin with, we have to have a main method somewhere. And already mentioned it a few times. We need it accessible from the outside. So it's got to be public. We don't have any objects yet. This is our initial step. This is step 0. So we don't have any objects that we can refer to. That's the thing that's going to be a big deal here in about 10 minutes. So it has to be static. That means we can look back at the class design, not any particular instance of the class. It's not going to return anything when it's done. We're in a strictly typed language, so we always have to keep track of what type of data we're using. That's going to be a big thing for the next few minutes. We're talking about methods is return methods. We have to keep straight the type of data that's returning, because the Java virtual machine is going to set aside that much RAM for it in advance. So we always have to keep track of that here, which that's where we get the biggest speed increase over Python, because Python has to wait. Well, one of our biggest speed increases over Python, because Python has to waste a bunch of time figuring out what type of data we have every single time, because it doesn't bother to remember it either. So it's not like it'll figure out we have an integer once and then remember that that's an integer every time. It has to refigure it out every single time we use that number. So in a strictly typed language, we have to be explicit about what we're typing. Those words do apply to a strictly typed language. I'm going to use them regularly and then spit out the formal definition. I was thinking about halfway through the semester. The formal definition of the formal definition. I'm just going to use those words, explicit and strict. They mean very precise things. So we have to be explicit about what type of data we have. And the computer is going to be strict when we're using that type of data. Oh, and then we have to call it main. The Java virtual machine is going to call a method referred to as main. And well, that's our initial step 0 in our software, the very starting point, which means that's going to be started from a system terminal, PowerShell, Bash shell, command prompt, but someplace where there might be some arguments coming in to help start the software, right? I guess the most common one might be, you'll probably all seen software that always opens back up to the last place you were. Accounting software is the most extreme example of that, right? Because we don't have different sets of books. Accountants have one set of books. So we don't have a whole bunch of files. So the software needs to always remember where it was. So we need a place for arguments like that to go. And we don't know how many of them there are. So we're going to say we have an array. That's our other big thing. Square brackets, everybody's seen that before. We have an array of strings that will be coming in, and traditionally we just call it args. Yes, that's very true. In fact, most accountants are like that. Some are more organized than others. Some might have lots and lots of, so switch it up a little bit more. So everything that we've run so far goes inside of that main method, right? That's a very important thing to notice about object-oriented programming. That probably another one that happens in the background with Python. So everybody's seen Python before. It seems like we can just write code in Python and it runs when we hit run. In the background, the Python interpreter would take that code and rewrite it into a constructor for an object. So it does actually run from inside a method. Otherwise, we don't have a good way to put it on the stack. So in object-oriented programming, even though it looks different in our text filing in Python, which I know everybody's seen before, in object-oriented programming, we can only run code from inside method. Outside of the method, we can do some declarations. Like we can go ahead and say, okay, we have this integer that we're going to use all over the place. We have this string that we're going to use repeatedly, and all our global scope variables, technically data fields, but I think most people are more comfortable with variables there. All the global scope data we can put out here. But for the instructions that actually, where we're actually doing stuff, they have to be inside of a method, which technically is something you saw before. You just didn't see it because it was automated in the background. Whenever you write just a text file of Python code and hit run, it does actually turn that into an object in the background, and all the stuff that you just put there in the file gets stuck inside of the constructor. In Python, constructor, there's only one. In Java, we have lots of constructors, but we will see that soon. Main thing is we have to run from inside a method. And I'm just going to do some quick examples. So let's start a couple integers and do some math with them. So maybe we have an integer x holding the value 3, end of instruction. Then I'll set up some spot in memory to hold another 32-bit integer. Reserve is another 32 bits in RAM. We'll call it y and stick the number 4 in there. This part's kind of trivial. And if we add those together, an integer plus an integer is always going to be an integer. Right? There's no place to introduce fractional values on that. So the result of adding those will be an integer. And then we can print that out, which is usually abbreviated. And most any of your decent IDEs to work with Java in, you can type S out and then hit tab and it'll do the system.out.println. So the operating system's standard output, print a line to it. So the console. And here we can just print out whatever Z is. What we've seen before, right? Nothing too special there. When we hit around, oh, whoops, I'm in a web app. So I have to wait for all this. I didn't mean to hit the run button. We saw last week there's a way to run the file, just the file we're looking at. I'm just going to close out of this because I didn't mean to hit run, which I forgot to look over the weekend. Notice the run but options on the run is to run the whole project. Same thing up here, run project, test project. Oh, run file, there it is. We can also run just the file we're looking at, which is Shift F6. Last week I remembered the keyboard shortcut, but I had no idea where the button was. So it looks like it's way down here. It doesn't even have the little green thing beside it. But F6 is our regular run button. If you hold Shift and push F6, that will run just the file you're looking at. Oh, well, that's going to be a problem. I'll come back and do this. Sorry. I'm going to copy this over to a regular project. Something I was expecting to be there has been deprecated, and I did not realize that. That's what that error message is saying. Cross boot class path. We can't have we'll kind of work around that. So I'm going to create a new a new thing here that is not a web application. I just very quickly created something, called it, whatever I called it here, Java application 11. Probably should have gave it the same name I just gave that other one, right? So I'm going to rename this. But if I start typing the name here, there's a bunch of other places where that name's typed in the automated process. So if you need to rename something, right click on it, and under refactor, that's the verb for cleaning up your code, making it look nice. Once you get it debugged and working, it probably kind of became a mess of code along the way. You want to clean it up and make it look nice. And renaming is under the refactor button. So if I rename this here, I can rename that with the same name I gave the other ones, which was methods 1. Refactor. So that renamed everything. The package is still different, but we'll deal with that in a second. And yeah, my workaround for that thing that I did not realize has been deprecated. We'll copy and paste from here over to that other project. So still very, very easy. So one thing is we need this name to be the same when we get around to using that. So I'll come back to, whoops. I'll copy all that stuff and replace this main method, which was automatically generated with that. You will want to type the main method a few times just to commit it to memory, but it's always exactly the same. So that's a good one for the computer to type for us. But you still want to remember how to type it. Right, so now I lost track of which one's which. Definitely don't want to have 2 files with the same name open. Okay, get back to the one that I know for certain which one I'm looking at. And now if I hit Shift F6, this is what we saw last week. We put all of our code in that same, in the main method. It runs fine. But as things grow, we're missing this ability, right? If we drew it in a flow chart, it's like we have this part. We even have 3 lines. Yeah, there's even 3 lines of instruction there. So we have this part, and then our output down at the end. But as the program grows, there's going to be all those other parts, and that's going to get a mess to keep track of and keep straight. So the first step in keeping things organized, nice and clean, because, well, we just looked at the word refactor, clicked on that in a menu. We know we're going to be refactoring our stuff. So the first step is to modularize it so that we have small chunks so that they're easier to clean up. So let's put this in a method. And copy and paste. And we've seen what a method looks like, sort of. We need this to be accessible. We have multiple words we can use. Public means other software can access. So something else. In our main method, we need the operating system access, but other software can access it. So essentially, if we create an instance of this object, of this class that we're designing, you know, methods 1 m equals new methods 1. Create an instance of our object. We'll see that in more detail soon. We want to be able to access a method that has to be public, because almost any place we would do that is a different piece of software than this particular file. We also have the keyword private, which means it is only accessible from our file here. And private in Java really is private. There is no way to if we make a private method or a private data field, there's no way to access it from outside of this text file. If you guys work with C#, we can serialize a private field and have a place where we can sort of send input to it. in a roundabout way of going through another file. But we can't do that in Java. If we say private in Java, the only access to it is the text file that we write it in, or the class we write it in. If we put another class down here, down below, we would not have access to our private, anything private. We also have protected, which is just like private, except child objects will get that. We'll talk about inheritance soon, but I know everybody saw that in the previous class. We start with a generalized object, then we make a subclass of it, a child object, where we add more details and get more and more and more specific. So protected is just like private, except that the child class has access to it. So it fits really nicely with the word inheritance when we get to our object-oriented specific stuff and talk about that in this class, because then it's like private, protected is like private to the family. Like we would use that word in normal English, right? There's private stuff in your home, but it might be your parents' private stuff, but you have access to it. Right? Or your, for other people in other age groups, it might be your kids' private stuff, but you have access to it because private means your family unit, not necessarily extended. So we have all three words, but in our case here, and for most stuff, it's going to be public. A lot of times when over the years, I'd start thinking about that, whether things need to be private or if something should really be private. If I have to think more than a few seconds, I'll just make it public and leave it off the documentation. Like this is a lot easier. I'll just make it public and then not put it on the documentation, then nobody except me knows it's there. Just kind of like private, but it's still accessible. Like if there's some debate on it. So we need a public method. And I'm gonna do this wrong first to show an error message, a very common error message. So, well, static was the next keyword in our main method, but we have to say what it returns. What I'm going to do is copy this code down. So instead of putting that in a variable, we'll return that result of adding them together. So the result's going to be an integer. We're going to return an integer, and then we need a name for it. So publicly accessible method that returns an integer, and I'll just call this adding. That seems like a good name for it. And then we need a couple parameters in order to make adding happen, right? Adding to binary mathematical operation, we need two numbers in order to add them together. Those are parameters that are just generalized at this point. I'll call it X and Y. And we're still in the strictly typed language. So we have to say what type of data will be passed in. At least for tonight. We'll see generics very, very soon. But for tonight, we still have to be specific about it. We know there's going to be integers passed in here. Integer Y. And then I'm going to do all this code. I'll copy and paste this. I don't know what happened with the end ending. Oops. I think these are probably on the wrong line. Whoops. Back. There we go. And white space does not matter. White space is only for our own benefit. And then instead of storing that somewhere else, I'm going to use the keyword return. So we have a couple integers, and then we'll return what their sum is, just like the name for the method implies. A nice descriptive name. Don't be lazy with typing. I'll extend that out, adding two numbers. It's really, really easy to type a couple words there. Then we have our conventions, what we're going to call beans, some coming up soon, where we just all kind of do things, agree to do things, write our code the same way in Java. Gives us extra power that we don't have when we all do our own thing independently. I'll get to this error message in a second. So And that is variables and method names have camel case, spell them out fully. So X and Y probably aren't good numbers here. So instead of X and Y, I'm just gonna call it first number and second number. Like on a board, or in math class, we write X and Y because we have our pencil and paper or a whiteboard or something, right? And it's really slow to write things by hand. That's not the case with typing. Don't be lazy with your typing. It's definitely beneficial to do that. So then instead of X here, I should probably fix that number and then come back to this. Notice if we take in this integer X, we get this error message saying X has already been defined. We can't create a new X. That's going to confuse the computer. Right? We can't have two different things called X. So what we fix that message is just take off the declaration and make that a simple assignment because we defined it up in our parameters. Now I'm going to put that back to the better name. First number is X. It's going to replace X. I can't seem to spell today. First number, and then Y will be our second number. And then we'll just return the result of those. First number plus second number. Which isn't bad to type, but where's my curly brace guy? Curly brace disappeared for some reason. Return. Oh, is the little box not going to pop up? Great. Control space brings up your predictive text. Usually it pops up on its own. I found in more IDEs than not, if it's not popping up, go back to the last thing. Like I would take out the in there, type return, and then let that box pop up. But it's not popping up for some reason. So control space will pull up your predictive text. And then those long variable names and long method names I just mentioned, we don't even have to type them. We really only need the first letter or so. Well, we could choose them from the list, but if we type the first letter, we get a very short list to choose from. By the time I type the first two letters, there's only one option on the list. There's one option, and then the crossed out things on that list are items that have been deprecated, but they'll still work. So don't use this, but it won't crash if you do. At some point in the future, it's going to be removed from the language. Finalized is going to be removed from the language. But it hasn't, so stop using it and go back to old code and take it out of old code. But for now, it will still work. And then we only even have to type that first letter. Again, I don't know why that's not popping up. So control space will pull up the list, and then you can just choose it from a list. Which is usually a good idea because somehow I erased my curly braces at the bottom. I must have bumped the little touchpad while I was talking and typing and doing several things at once. Humans make typos, not machines, right? The machine is only going to make a typo during the debugging process, and really that's our typo for leaving debugging there. So the machine will never make a typo. Let the machine do as much typing as you can. So this kind of does the same thing as these lines up here. So instead of these up here, I'll call this, and a method call is going to look very familiar to what you've seen before. We throw in the name of the method. So in our case, adding two numbers, And if necessary, pass in any arguments to fill those parameters we left down here. So like our first number would be we pass in a 3 and a 4. And that error message is the one I was leading into. I know we'll talk about why that's there. So that should look very familiar. And I left the S off. Okay, now it's probably the error message I was expecting. Okay, yeah. I left the S off, so I could not find that method. Unknown method, unknown name, whatever it said. But this one, we'll see this a lot because our main method has to be static. Talk about that, right? We can only start our main method from the class file, the class definition, the blueprint, the design for an object, because we don't have any objects at step 0. So that has to be static. But this method, this normal one we wrote here, we didn't say it's static, so it's not static. It's just a normal method that we would call from an instance of an object. So we get this non-static method cannot be referenced from a static context. And I believe I mentioned before the error messages and all the stuff in the compiler, the predictive text, the underlining, suggestions, all of that stuff comes from the compiler. So if you just wrote this in a text editor and then went to your terminal and Java C and tried to compile it, that's the error message you would get. Non-static method cannot be referenced from a static context. There's 2 ways to fix this. The first one's probably kind of obvious, right? Okay, it's a non-static method, so let's just make it static. Static. Okay, that fixed it. And if I hit Shift F6, it's going to run and do what we expected it to. But that could lead to other problems, right? Because that seems like something that's going to cascade on through. If anytime we call a method, it has to be static, when do we stop making methods static? Because eventually we don't want to look at the class design for every single thing we do. So a better method is, well, everything in Java is object-oriented. We already made a class. So to access this method in it, well, we just instantiate that class and then ask the object that we create and ask an object for that method. So our class name is methods1. So I'll make some methods1 type data. This thing seems like a good name for the reference purpose here. This thing referring to this file that we're in, and that's going to be a new methods1 type of data object. So we instantiated the class that we were in. That sort of phrasing might seem confusing to a human, but a computer will never confuse it. The computer will know exactly what we're referring to, and we won't end up with the infinite recursive calls or anything trying to keep instantiating the class we're in over and over and over again, unless we tell it to do that later. So now we can use this object, the instance of our class, to call that. So this thing dot. Oh, there's the predictive text. Instead, it even popped up on the predictive text. Like, okay, there's only one method there. You must be trying to call this method. That is a much better way to deal with that static, non-static. Try to reserve your static instances for the times that need to be static. The big ones are like the main method, step 0. There's also some database stuff we'll see later where we need to do stuff before the program actually runs. But before the program runs, we don't have any objects to use. So we have to use static there. Also, things that are going to apply to all the objects. So for like an employee object, that's gonna be a very common thing, right? Even in trivial examples that we'll see in classrooms, like payroll calculators, we're gonna have an employee object. Maybe we want a counter to keep track of how many that is. So if we make that a static counter, then every employee object shares the same counter. So we just increment it by one every time we create a new object. And there's only one of those counters, no matter how many employee objects we create. So try to save static stuff for when we need static stuff. And that way you don't end up with that cascading thing of we have to start from someplace static, which means we can't call a static method. And then it just cascades all the way through your program. Before long, you have something that's entirely static. We want to avoid that. This will also be important when we copy this over to that JSP page. So apparently when I was originally thinking of putting those in the same file caused a problem. It didn't seem to like it. Does that make sense? Y'all see the commonality from what you've seen before, what we're doing here, understand those extensions and what the differences are. The computer doesn't have to waste time figuring out how many bits in RAM to set aside. Trying to figure out if it's a string or a floating point number or a Boolean. We set it as an int. The computer already knows to set aside 32 bits in RAM. And then we stick with that. So that's where a lot of our speed comes back from the open type languages, which can be a little bit easier to use. And we can do that. There's another word that, so that'll add two numbers. But what if we wanted to do this? I'm going to change the Z. I'll call it couple ints to indicate we're adding a couple ints. And let's do some more adding. But maybe floating point numbers this time, right? Oh, I'll use double. Pretty much only game developers use floating point numbers anymore. That adds up very, very quickly when we do 140 frames per second. Otherwise, most machines are 64-bit machines. So we're sticking our data as it processes in the CPU, we're using 64-bit registers, which doubles fit right inside of, and we don't need to worry about saving it. So for this class, we'll be using doubles on most stuff. We saw last week, if you use the smaller float, remember to put an F at the end to indicate you want the smaller route. You want to save some bits there. But pretty much only game developers still use floats. Everybody else uses doubles. I'll call it couple reals. And if I try to call this, well, we have this method called this thing, the object we're designing right now, adding two numbers. But we kind of hit a problem, right? Because this time we're dealing with floating point numbers. That method we created only adds integers. We can't pass a floating point number in to fill that integer space. Those are different types, right? We get an error if we tried to pass in 4 and 8. We get this error message. Oh, not that error message. Oh, an integer can go to a double. I should have went the other way first. But that's going to return an integer, and I can do it here for sure. 4.3 and 8.7. If we have some real numbers, that works a lot better. We get an error. It's like, okay, that method only works with integers. There's something that well, we definitely can't do in Python. It's not easily, technically, we can tell the computer to do whatever we want it to do, but we can't easily do it in Python, so most people just don't do it. And that is what's called overloading. We want to use the same symbol for more than one thing. You'll probably encountered this before, right? Like right here, we're doing math with plus sign. But we also use a plus sign to concatenate strings together. There's more than one use for that one symbol. That's called overloading. In C++, we are free to overload anything we want. That's one of the dangerous parts of C++. We have unrestricted control of the machine. We can take any character on our keyboard and give it any number of uses we want, and the computer will figure out at runtime which one of those uses it's supposed to be applying. So one of the things they put into Java when they first cleaned it up was no overloading operators. So we can't add more uses of the plus sign in here. Overloading is restricted to methods because that's nice and clean and organized. So we can't make another use for the plus sign in Java, but we can make another use for this name right here. We can make another use for adding two numbers. We can give that more than one purpose. Because really it's a symbol. Adding two numbers is for a human. That doesn't mean anything to the computer. That is not what the computer sees once we compile it. So the thing the computer sees, we can give more than one thing, more than one. We can make it do more than one thing, just like the plus sign that we're familiar with. It can add numbers or it can concatenate strings. So we'll create another method. Again, we want it to be public. Only this one is going to return a floating point number. I'm going to use that word. I'm going to use that word throughout the semester. I'm going to say floating point number, but almost always use double, even though we have float type. They're both floating point real numbers. So we'll be using double numbers extensively, but floating point numbers fit nicely in sentences. Double precision floating point number is what that stands for. I guess I could say the whole thing. And so we have our accessibility level, the type that it's going to return, and we want to give it the same name as the previous one. Go ahead and set up the parentheses to get ready to accept, put in parameters to accept arguments into. So the curly brace in there and sort of block out the method. For those who haven't had me in class before, I usually like to make a big deal out of jumping around and making code. Right? The final result needs to be left to right, top to bottom, a certain order for the computer, but that order is almost never the way we think about it. And it'll be more productive to jump around in the code and put it together the way you think about it, because then it's following your thing and just make sure it's in the correct order by the end. And the change here is that we're going to make a couple floating point numbers. I'll even call them the same thing, first number, and make those doubles. Double first number and double second number. In general, ints and doubles are our go-to data types for numbers. We use the other ones, like the smaller versions of integers, bytes and shorts, if we need to save bits. Long, if an integer won't hold it, if we have a really, really big number. And same thing, doubles, double is our go-to, and then we use floats if we need to save those other 32 bits, between a 32-bit number and a 64-bit number. We notice that it's all the same except for the data type, the parameters that we feed into it. Then it's going to do the same thing. Wait, I don't know why I have an assignment there. There should not be an assignment there. We take in that number, and then we add it. We add the two numbers in return. I was talking and typing and doing several things at once. Sorry about that. Does everybody see why that line I put there was kind of unnecessary and would cause problems? Let me hit Control Z till I get back to it. Now, if I tried to pass in, like, say, 7 and 2, well, we can't add 7 and 2 anymore because we reassign them as soon as they get down here. So those lines that I copied and pasted should not be there. My mind must have been elsewhere when I did that. And the same thing here, we're adding 2 numbers. So for a stripped down, clutter-free class example, we just need that return statement. Return the result of adding those numbers. First number plus second number. Which I typed even though I just made a big deal a few minutes ago about letting the computer type that. So you see now we have 2 versions of adding 2 numbers, and our restriction when we overload stuff is they have to be distinctly different. If we pass in 2 integers, the computer's going to run this one. If we pass in 2 doubles, the computer's going to run this one. And they have to be distinct and unique enough that the computer can tell them apart. We're going to put it as an example. I'm going to erase this line and make another one. So if we had a string x equals the world, and we can say dot to get to our stuff, and there's some overloaded methods on here, like substring. There's a version with 1 integer, or there's a version with 2 integers. We could not have more, we couldn't have multiple versions that only took in 1 integer. We can only have one method that takes in 1 integer. Then we can have another method that takes in 2 integers, another one that takes in 3 integers, and that way the computer can tell them apart. So sometimes if we run, we'll add, it doesn't hurt to add extra parameters that you just don't use to help distinguish which one's which. But that's our restriction. The computer has to be able to tell them apart. So as long as they're distinctly different. So I'll make a double called a couple reels, and we'll refer to our object here, this thing, dot. And now we have 2 versions of adding 2 numbers. Oh, whoops, I spelled that wrong. Let me fix that. There we go. I was trying to make a point about overloading and I gave them different names. They have the exact same name, just different performance from each one. Oh, here's that thing that I was talking about. The predictive text is gone when I came back to it. So what I do is usually just take out the last letter or 2, usually that dot, and then re-put the dot in there and then get the predictive text back. Okay, now we have the predictive text saying, okay, there's 2 methods called adding 2 numbers. Which one do you want? And then we can see the difference between them. This one takes in 2 doubles and returns a double, which we're putting in the spot to hold a double. The other one takes in 2 integers and returns an integer. So choose the one we want off the list and then pass in some numbers. So like 3.14 or 2.82 or a couple good floating point numbers. And then we can print that out. So S out, couple reels. And when we run this, you can see we have multiple methods going there. So we've already seen methods. I figured there wasn't a need to get super in detail, right? We already saw the main method, and this course stretches out for 16 weeks. So we'll fill in some more details along the way. The basic idea of methods and modularizing our code, making it easier to manage what our keywords mean, and overloading is going to be a big deal. The 2 prerequisites for this class, and I use Python these days, and we cannot overload in Python. We cannot easily overload to the point that most people just don't even bother with it. And some of the things that you're probably thinking about in Python that are already overloaded, or like our print statement, where we can use commas or concatenate the string together, that was written in C++, not in Python. Is the reason it's overloaded. So yeah, it's that hard. Yeah, we have to do that too. I don't think you would have seen overloading before. But does that make sense? And some languages do allow us to overload operators as well. So you can also make multiple uses for like the plus sign or the ampersand or any symbol you have on the keyboard. It's easy to get lost in that. So usually not a good idea. Why when they cleaned up C++, they decided to restrict overloading just to methods. Then we have a nice little set of words descriptively telling us what the thing does. That's the basic idea. It's probably a good time for a break, right? Looks like it's been over an hour. Does 10 minutes sound good to everybody? I see head nods in the classroom, the Zoom call. And then afterwards, well, basically this, what we did here, gives us a way that we can run this same code in the main method and in the JSP. Because now all we have to do is, instead of doing that in the main method, we'll just create an instance of this class over on the JSP page and instantiate that. But a couple other things I'm gonna look at first. 10 minutes sound good to everybody? Anybody in the Zoom call have feedback on that? Thumbs up or anything? Oh, there is something in the chat room. Okay. So my laptop, that clock says something weird. My laptop says it's 7:12. So we will get back to this at 7:22. And I want to take a look at Java docs when we get back, because that is a really useful thing.